product that we've never done before. It was important to us that it looked futuristic. But long before what it would look like, I imagine what it would feel like.
Hey everybody, welcome to Rightbrainers, where we unpack the latest trends in technology and creativity through real stories of creative breakthroughs, brought to you by Z by HP. In each episode, we'll dive inside the creative minds of the world's most innovative thinkers. I'm your host, Tito Hamzy, a man on a mission to get his left brain to understand some of the biggest right brains out there. It is my absolute pleasure to introduce today's guest, a design director who lets emotion lead the way, and the man behind the world's first and only street-legal single-seater supercar, Mono. This week, I chat with Ian Briggs, co-founder and head designer at Briggs Automotive Company. Welcome to the show, Ian.
Tito, fantastic. It's a pleasure.
What's your earliest experience with cars?
My first memories were on the shoulder of my father, watching rally cars in the forest. My brother's 3 years younger than me, so he wasn't there, so I was younger than 3 years old. And had my feet tucked in his jacket all day long and his hood up around me. And he just passed me sandwiches, this little 3-year-old body. My dad's head was like as big as my body. But that's how it kind of started, just going away racing weekends with my father, with my brother, my grandfather, and just loving machines, the sounds, the noise, the smell, the competition.
So I'd imagine growing up, going to the racetracks, you get a little older, get excited to learn how to drive. How was that experience?
I remember the very first time I went to a motorsport event on my own. So I went in, it was my mum's car, which I was able to drive. And it was the first time I'd ever been to a race meeting without my dad. And I was there and it felt like a moment of freedom, of arriving kind of thing. And I was able to go wherever I wanted and have a little look around. I suddenly felt really grown up.
Since then till now, things have changed tremendously. Briggs Automotive Company, you're doing some pretty cool stuff over there. What's your design process and the aesthetic? Like the front of the car, it looks like a spider on steroids. Like I was looking at it with the light underneath and like all these, shafts and bars going from the middle to the end. And just looking at it, it looks fast. Where do you start in the design process and where do you go from there?
The way we approach design, the way I've always approached design, but also with my brother Neil, who's got an engineering background, I've got a car design background. The traditional way of designing a car, let's say engineering design what's called a package, and then designers kind of make it look pretty. And that doesn't really do justice to engineering. It doesn't do justice to design, and it doesn't give both parties the chance to really collaborate on the concept. And so the way Mono looks, for example, at the front is very much a function of the things that it is. It's a single seat car. We're trying to have a low frontal area to reduce drag. And we're trying to put everything either in front of the silhouette of the driver or behind, or we're trying to put it in front of the tires or behind, because everything else is just drag. So that's why, for example, the headlights, as you said, they've moved to the center of the car. The dip beams are to the outside. And that allows us to just have as much open space as possible, because we just want the air to come in, cool the engine and leave. We don't want to slow it down. We want the least amount of drag. So the aesthetic of the car is very much a feature of its engineering, of its concept, but it's very much engineering and the conceptual design driven.
And how much of that is form versus function? How much do you give and take with the engineering side of things to make it look pretty versus function at these high speeds where you're trying to break records?
And certainly in the case of Mono, we very much wanted something that was athletic, a lightweight aesthetic, the way that skin is tight across muscles on animals, on humans, the way trees grow, the way that lines run into other lines. Very much this organic but lightweight aesthetic. That's certainly what the end inspiration was.
Yeah. How much of this is purely selfish? And I mean that in the nicest way. How much are you designing this car for yourself, and how much are you designing it for the customers?
Well, completely. I mean, the project grew out of Neil and I. He was racing, I was racing. We both had nice cars. We're doing track days, and we both wanted this car. It definitely started with that. And whenever we evaluate anything, we evaluate what would we want if I climb in, press the button. What do I want to see? The name of the car appear. Then I want it to tell me all this information. And, do I want it to say my name? Maybe I do, maybe I don't. Everything we do is we're just imagining being there. That's the journey I love as a designer. And I always come up with ideas when I go to sleep. Those last few minutes before, when you close your eyes, everywhere's dark. There's no more distractions. And I always think about some problem to solve, or I'm always imagine before the car existed, I imagine seeing it or sitting in it or hearing it. And it's always from the point of view of what would I like. Of course, I know that on some aspects I'm slightly different to others. I know how I'd like to use the car, and that's how the majority of the guys use the car. But there are others as well, and so that you do have to be pragmatic as a business owner and say this is what customers have asked for. It's not something I perhaps would want. It wouldn't be how I'd make my mono, but it's what our customers want. That's what we'll do. They're very much just like personal preference things. My mono would be white with visible carbon. It'd be super clean. It'd be the original concept. But some guys want to make the color scheme represent something that's important to them. And we work with them and we do that, and that's fine. It's mostly based on us, but being pragmatic as a company owner as well.
You work with your brother a lot. He handles the engineering and you handle the design?
Yeah, basically.
What's that relationship like?
There's a mutual respect there. We both love motorsport, and we love the aesthetic that comes from just basically following a pure brief. I think that's one of the important things with mono is, unlike other cars, because other cars are based on a method of transport, and there's always a compromise between how sporty or how comfortable, how luxurious, how affordable. All you're trying to do is produce a piece of equipment which is like your ski, like your snowboard, like a parachute, like a canoe. It's purely designed just to do that sport as good as possible. Then there's a focus. Every decision you have to make is based on, am I making it quicker? Am I making it lighter? Am I making it perform its function better? And there's an aesthetic for the engineering and for the design, which comes out of that, which is what you get in motorsport. And that's why racing cars look cool, because they're just totally focused on that one very clear goal. And we both want that same result. And so ultimately what we do complements each other. And of course, being family, there's a level of trust as well, which will never be broken. And so, on balance, I think it's a strong partnership that we've got.
Very cool. So when you were designing like the new mono in these programs and, you're focusing on that emotion, what would be a single word, maybe like a theme that would be running throughout the design of that car? It can even be a sentence. What would be something that would just condense down that emotion? I just want to understand that.
That's a tricky one. Because it's a product that we've never done before, it was important to us that it looked futuristic. So it was always intended to be science fiction. It needs to look sci-fi. It's got this very white, organic main body and these very dark black engineering surfaces below. You look at any of the Star Wars sketching or any science fiction movie, because of that environment in outer space, you've either got bright sunlight or total blackness. And it needs to look science fiction. And I keep coming back to this lightweight aesthetic. It's got to look light. Traditional car design is based on volumes. You talk about a 3-box saloon. So there's a box at the front with the engine. There's a box in the middle where the people are. And there's a box at the rear for the luggage. Designers talk about putting mass at the rear if the engine's in the rear and making it look muscular. We didn't want any of that. We were much more inspired by motorcycles in that respect, because we wanted an aesthetic which really showed this is a machine and I'm just putting the thinnest necessary surface over it to make it move smoothly through the air. And once that's no longer necessary towards the rear, I'm just going to let you see the machine. If you stand at the front of mono, you basically see almost nothing of the technology in the car or nothing of the engineering. If you stand at the rear, you see the exhaust, the gearbox, you see the coolers, everything.
So moodboarding, what would that look like for this project? Are you grabbing like images and colors and thoughts?
Interestingly, there were no cars in our mood boards. The Predator drone? It's very rounded, a very soft shape, but then there's a very sharp line, which is along the trailing edge of the wing and down the side of the body. When shapes are too soft, they look inflated, they look fat, they look overweight. We don't find that attractive in nature. We don't see that in nature. So forms where we have a combination of soft aerodynamic shapes, but then with tension or with sharp edges that make it very clear it's not inflated, it's not overweight. Very much this kind of skin stretched over either muscles or a machine.
Yeah. Designing that and figuring all that out. I mean, you can't be possibly going and creating each version of that or each idea that's coming to your head. How do you go from concept one, the beta, to the manufacturing? Okay, this is what's going to be in the car.
I mean, it's a fairly well-trodden path, the design process. We start with a brief, so we decided what we're trying to achieve. We've got some market research about potential competitive vehicles, things like that. But the very first stage is we start off in the computer with a mannequin, with a human being. Where's the engine going to go? Where's his feet going to be? Okay, we don't want the axle behind his feet for safety reasons, so that's where the front wheels go. The engine, how big's the engine? We've got a kind of an idea of a target weight, so we know what kind of power plant we want. We know approximately how big it is. That gives us a wheelbase. Just with those first few steps, you start to create the positions of the wheels and tires in space, the driver's head in space. And then we just start doing some sketching. We're looking at the things that inspired us. In the case of mono, And there's a video, I'm not sure if you've ever seen it, All Is Full of Love by Bjork. It was very much the inspiration for I, Robot, the movie. And in it, it's a very clearly a robotic machine. There's no attempt to hide that it's a machine, but there is a face. There's a chest, there's hips, and there's some elements of the legs, but they're very clearly just plastic covering parts of the machine. From other angles, you see clearly it's a machine. And that was something we wanted. We wanted to cover up the parts where aerodynamics would give us a benefit or where we're legally required to for the wheels, tires, things like that. But in other places, we wanted to show the machine. We wanted to show this lightweight machine and use that as the kind of aesthetic. It was very important to us that it was clearly something from the future. It wasn't inspired by the past. It wasn't a little bit like something else. So you'd start with all the sketches, and then as you start to develop the aesthetic of the car, ultimately what we end up with is what we call a clay model. So then we've got the package of the vehicle. It's in 3D. It's on a table. We did a quarter scale. We've modeled the envelope of the tires, the size of the person, the chassis, where the protection structures have to be. And then we start with clay and we start to try and emulate the 3D sketches that we found best answered the brief and best give us this feeling we were after. We try to emulate that with the clay model. And eventually the clay model gets scanned. You go back into the computer and then you start going round and round as you start fine-tuning the design.
I heard use AI and generative design to condense that process of figuring out what will work and what you think will be better. So can you talk more about that?
I think you're referring to the project we just did with Autodesk, which was the generative design wheel. And the traditional way to design something like that from an engineering point of view is you would come up with a 3D model, you would optimize it with FEM, you'd look at where there's stress points, you'd look at where there's areas of too much material, and then you'd remove some material from the areas that are too strong, you'd add some where they're too weak. And this would be like an iterative process you'd go through, like 2 or 3 loops. The disadvantages of it is you don't really know how far you could potentially go. If you said, if I had 1,000 iterations, how light could I make this wheel? Well, you never really get to see that. You get to go maybe 2 or 3 iterations. You seem to make some decent gains. And that's really where you have to put your pen down. With generative design, you can literally get 1,000 iterations. And you can say, I don't care how it's made. I don't care how expensive it will be to make, but just show me the least amount of material that will take these loads and obeys the rules that I've put in, because obviously for a wheel, it can't stick out beyond the tire. It can't get in the way of the brakes, things like that. And you can very quickly see what potential benefits there are to be had. So we had a wheel, it was a wheel center actually, because we have a carbon fiber rim. And we found quite early on that if we said money, no object, in other words, we're going to 3D print this center out of the strongest material, we can probably save about 1.5 kilos. If we went to a fairly simple method of manufacturing, which was 5-axis milling, we were able to get 1.2 kilograms anyway. So you could see it's an exponential curve. We're going to spend inordinate amount of money to get to this end point and save a very small final amount, whereas I can get 80% of the benefit and I can get it for an affordable cost. It gives you the overview. It lets you see this is what happens if I do everything. This is where I am if I do nothing. And then I can just pick how far I go.
That's pretty cool. A lot of people that are going to be listening to this are creatives or might be starting out or might be down that road. So what I want to know is where do you spend most of your life on the software side of things, like specific technologies? For me personally and the rest of the design team, most of our world is Alias, Autodesk Alias. It's a NURBS-based 3D surfacing program. If CATIA or NX is the engineering kind of industry standard, Alias is the surfacing one. Is there a heavy learning curve on that? Not really. I did a 1-week course. I mean, I'd used lots of different softwares. So it's like once you can speak 2 languages, then the third's not that difficult because you kind of understand the structure of things a little bit better. So no, it's not a difficult thing to learn. It's a very good program for designers in that you can sketch in 2D and 3D over the 3D model of the car and then extrude surfaces from splines and manipulate them by moving control points and things. Very good, quick visualization. And then there's a partner program called VRED, which is what we do all of our kind of visualization in. And in fact, that goes as far all the way. That same VRED engine is the configurator for customers when they come to the factory to configure cars. So we go all the way from the very first sketches in the computer all the way through to the configurator that's customer facing using Alias and VRED. So why did you start using 3D printing?
I'll be honest, I'd never thought about it much. I'd been offered it a couple of times. A couple of people have said, should we get a 3D printer? But they didn't use the word 3D printing. Everyone used the word rapid prototype. And it just got me into a bit of a mental rut about thinking, we don't make that many prototypes. For the amount we make, we might as well just send them off to a place that can do it for us. But I met some guys from a company called DSM who do a lot of the plastics for 3D printing. And they opened my eyes, certainly, and the rest of the team's eyes. And what we realized is mono is a high price item, but it's very low volume. And one of the challenges that gives you is you can't invest the kind of money in tooling that the big guys can. Like a typical part on a car in the car industry, if you're making 7,000 a week, you want it to cost you €1, but you don't mind spending 100,000 in tooling to allow it to cost €1. We can't do that. We're making 30 cars a year. So we don't mind it costing £100 or £200 each. But what we want to do is avoid the tooling. So we've got lots of machined from solid aluminium parts. They're very expensive parts, but the customer gets a brilliant part. You get a very lightweight part. And because we order them in batches of 5 and 10, we can change the design anytime we like. We can optimize it, reduce weight, or add extra functions. So this kind of low investment, high price point, I think means that we're one of the first companies that can start to look at 3D printing properly, because that's what that is. Given that you've got to create the design however you make the part, you've got no investment up front in a tool, but you've got a slightly more expensive part than let's say a traditional injection molded part. But it's allowed us to do all kinds of things which we couldn't do in the past. Really specialist parts that support wiring in places where they might have vibrated or rubbed on things. We can make perfect little parts for us instead of having to find something off the shelf and adapt in the design slightly. So it's really allowed us to optimize the product. We've got about 40 printed parts on the car now, doing all kinds of things. In fact, we've got 3D printed inlet manifold on the new Mono R engine, which is probably the most critical part of the car, and then all the way down to just really simple, just little covers on lights and things like that, which just lend themselves to printing.
In terms of technology, what's still holding you back? Like, what would you like improved? What part of the production process do you think has the room for most improvement?
It's not really the production process, if I'm honest. At the volumes we're doing, the assembly time or even the production time, it isn't really the big factor.
Okay.
We've just done the Mono R's got graphene in the carbon fiber body, so there's 44 carbon parts on the car, and they all use graphene. We were able to take about 15% of the weight out. Means we saved about 9 kilograms on the new car compared to the old car. Graphene is the strongest material known to man. It can be produced in sheets 1 atom thick. But basically, graphene has lots of incredible properties. We have a carbon fiber bodywork, so that's a mixture of carbon fibers and epoxy resin. And that's what, whenever people talk about carbon fiber, they're actually talking about that composite of epoxy resin and carbon fiber. Well, if you add graphene to the epoxy resin, you can get improvements in toughness, in tensile strength. Mechanical properties are improved. If you can improve them, it means you need less carbon. If you take the carbon out, you've reduced some cost and you've reduced some weight. So we were able to take about 9 kilograms out of our carbon fiber structures on the car by going to graphene. And we're the first manufacturer in the world to have done it on a production car. So what we're chasing is those innovations, and they're very much, obviously you need the resource both financially and you need it in manpower. But we're lucky in that we have a sexy product that attracts cool partners, and we've done lots of interesting projects from ceramic brakes, graphene and the bodywork, generative design wheels. So we're lucky in that respect. So don't feel held back in that respect.
Very cool. I'm all about driverless cars, like the safety and the efficiency in them, in theory. And if the world is headed in that direction with all these startups that are working on driverless cars and gravitating towards automated vehicles, how will your company make sure that the art and the experience of driving isn't lost?
I do believe that in some period of time in the future, we'll be driving electric autonomous cars. We probably won't even own them. I mean, I came here today in a car to go. It's an electric smart car. Don't own it. I just called it with my app, walked up to it, put the code in, sat in it and drove here. I don't need to worry about parking it, park it for free. But a car for some people has another function. A car has the same function like a mountain bike has for a cyclist or a snowboarder has for his snowboard. It's a piece of equipment that allows him to do his sport. People aren't going to stop enjoying driving.
Yeah.
And I think in 10 years' time, let's say, when we've got all these autonomous cars fulfilling the transport function, if someone was to see a car with a steering wheel, they'll realize, okay, that's for someone who just enjoys driving. He doesn't need to worry about carrying passengers, doesn't need to worry about carrying golf clubs or luggage or anything like that. It's just for driving. Nobody ever asks, where do I put my luggage on my snowboard? Nobody ever asks that question on a mountain bike. So it'll be a much easier product to understand. And I think we're right at the front of that movement. I think we're right at the beginning of where our car has no transport function.
I definitely think you're right. And it's going to be something where we're calling the cars for the transportation, the daily needs that we need. But then we're having this souped up piece of equipment, this souped up car that we're using for fun and using for leisure.
It's interesting because motorsport traditionally had two functions. One, the car manufacturer wants to show that they're capable of building the quickest car. They want to demonstrate that their competence, their technology. And the driver wants to show that he's a better driver than the other guys.
That's awesome. So generative design, 3D printing, designing for emotion. What's a breakthrough you see yourself chasing in the next 5 years? And will AI help you design for the future?
So I see in 5 years' time, mono, there'll be variants which would broaden its appeal to more people so that someone who says, I live in a hot climate, I want a closed one where I can stay cool, but I still want this focused driving machine. Or somebody who says, I don't drive my mono ever on the track. I just want to make sure I've got navigation and I've got the conveniences I need to basically just enjoy a weekend in the mountains. And then there's other guys who say, hey, I'm not interested in taking on the road. I don't need headlights. I don't need any of the things that are legally required in that respect. I just want it to be the quickest thing around a track. I'm going to put it in a trailer and take it there. And I want to measure everything I do. I want to know how much brake pressure I apply. I want to see every little detail. I want built-in data loggers. We'd like to take it to the point where its focus is now even more finely tunedly focused to those different users. But as a company, then we've broadened the appeal. So we've got the opportunity to sell more cars to a broader audience. That would be our probably 5-year goal.
Yeah. Does the mono have one hell of a cup holder?
Yeah, no one's ever asked that. People ask if it's got a sound system, but I always say it's got a 340 horsepower sound system behind your back. But no one's ever asked about a cup holder, so I don't have a funny answer to that, I'm afraid.
What keeps you up at night?
Well, I guess being boring, the normal things that any business owner might worry about. But I've got pretty good at pushing them out of my mind because obviously you can't do anything about that in the middle of the night. So I'm fairly good at switching into a different mode. And the mode I always switch into is I imagine things I like and I imagine the next product. I imagine what it might look like. But long before what it would look like, I imagine what it would feel like to be in. And that might not even be a car. It might be an aeroplane. It might be a spaceship. What would it be like just to be on a spaceship now on the way to Mars? Or what would I want where and how would it look around me? How would I feel when I look around? Or do I want to feel in a small space and feel safe? Do I want to feel in a vast space? Just kind of fantasizing about experiences. They're the things I enjoy doing. That's why I enjoy design. And that's where the design always begins, with a feeling rather than an actual look or an actual technical specification. They're the things I enjoy imagining at night.
So hypothetical question, money is no object and you can design a car for any celebrity, live or dead, person, historical figure in the world. Who would you pick? And I guess the aesthetic would be pretty different, right? If you're going to design something for Napoleon Bonaparte versus for some other cool person.
It's funny, we were on holiday a few weeks ago and we're all sat around and someone said, if you could go to any time, when would you go? And everyone went backwards except me. I'm not interested in going backwards. I want to go to the future. So if I did anything for anyone, it would be either now or the future. I suppose, the dream for us, and there's a bit of a selfish aspect insofar as what it would do for us business-wise as well. It'd be great if James Bond could drive mono.
Oh, that would be sick. I'm already imagining it. Thank you so much for coming on the show. I really appreciate it.
It's been a pleasure, Tito. It's been a pleasure talking to you.
After all of that, it's time we take a step back to break down some of the more right-brainy stuff for this left-brainy guy. Today, I'm excited to introduce our expert, Bart Massey, the creative director for advanced design at HP. Barty the Bartman, thank you so much for coming on the show, my favorite Dutchman. How are you?
Very good, Tito. Thanks for having me.
Yeah, no, the pleasure is mine. I'm happy you're here. Let's get right into it. Generative design. Sounds sick. Ian talked about it a lot. What is it?
It is sick. It's the future. Basically, what you're talking about and how he's applying it is it's kind of like the evolutionary design by algorithms. So what you're doing is you're having the computer and artificial intelligence generate a plethora and an enormous variety of options. And then you curate and choose out of those. Or if the artificial intelligence gets smarter, it'll be able to automatically do that for you. So instead of us pixel pushing things, it's going to be a completely coded, algorithm-based kind of process of natural selection in your design processes, basically. That's a whole bunch of stuff in one sentence, maybe.
I don't understand the words that are coming out of your mouth, but let me understand something. So
let's break it down a little.
Yeah. So you have a computer, you give it some parameters, and then it's using its mind, its artificial intelligence to figure out multiple different versions of whatever you're giving it?
Yeah, I guess I'm jumping the gun a little bit in the development that's going to happen in the next 10 years. But currently, you would feed it with algorithms that is mostly, let's say you wanted to create a part, and in this case, they're working on this wheel part, and it has to have a certain weight and a certain strength. And then normally what we would do is, in the old-fashioned process, you'd start sketching a variety of ideas and then you'd build them and test them out. Maybe you'd do some finite analysis in your simulations for strengths. But the new accelerated way of doing that is that more designers have access to these kind of deep simulation tools. And the process of designing becomes less of a human-driven intuition type process, but it becomes more of a process where you immediately go towards let the algorithm create 10 or 100 variations, pick the ones that you believe fit most with your function or aesthetic, and then select that and let that develop further. And with computer development and accelerated speed of innovation and Moore's Law, the doubling of computing power in the next decade, you'll see that accelerating so rapidly that the designer becomes more of a DJ, more of a curator of a set of rules than the actual pixel-pushing designer that is creating all the forms. You know what I mean?
Yeah. And what are the main use cases of generative design?
It's quite widely used in architecture, where by use of generative design, the actual language itself completely changed. But actually, if you look at the physics of it, and that's quite interesting, back in the day, a little bit of historic view of generative design. When they used to build like a cathedral or a giant church, what some of the designers did is they basically were hanging like a rope, and the natural form that it creates, they would then turn upside down, and that form would be actually a perfect structure to create an arch. So in effect, you could say the most basic way of design by natural laws is that principle of turning that rope upside down, projected into the future, add computer power, add artificial intelligence, and suddenly you're able to do extremely complex design challenges and do them faster and curate only to your requirements, your needs, your brand identity, the outcome that you want to be. So again, the designer becoming the orchestrator rather than I'm pushing these curves, I'm pushing these pixels.
And is it mostly in manufacturing? Is that where this generative design is happening?
Okay, so you have materials, you have generative design, you have 3D printing, and you have bioengineering. So combining it with DNA sequencing and bio, if you start combining those things together, you're actually looking at the future of what design will be in the next decades. And that's tying into a bit of a bigger perspective of manufacturing the last 100 years would be a process of removing material, CNCing, or, you put something on a CNC, or you make a mold by means of laser eroding or cutting, and then you cast in plastic or something like that. And then you assemble something in parts like a laptop. And it sounds kind of radical if you think about it, but the self-generative design, biomaterials, additive manufacturing, which is the link actually to 3D printing, means that now you can start layering things. And instead of removing material and then casting plastics in it or something like that, you're now adding layers. And what that allows you to do with different materials and the genetic type things, suddenly this whole world opens up of where what we will design will be more adapted to skin or to the human form or to the way we are built ourselves.
So 3D printing, I want to come back to that. But before we move into that, what is some specific software that is being used for generative design? Or if somebody wants to start getting into generative design, what is like a good beginner software?
Right. So there's numerous types of software. But for instance, Autodesk 360 Fusion is what Ian used on their car. So actually he has some photos with it actually, CNC'd Autodesk Fusion 360. I don't know if we're partnering with them at all at the moment, but they have free available software that anybody can just get in and start exploring, and really good tutorials. Another one is Rhino, which is Grasshopper. So that's very much code-based. Again, anything from growing things by means of just coding and programming, translated into a visual language. So it's kind of like node-based visual language. So the bar is a little lower. It's still a decent bar to get into, though. So you can start easy with some tutorials, but then as you get further, it really becomes a spaghetti of code that you have to really learn how to control.
Yeah. The people that are using generative design, is that their specific job? Or is this just something you pick up on the side?
I would say at the moment it is a pretty serious undertaking. However, if you look at, for instance, gaming design software, there's another big trend where game design software like Unreal 5 engine, Blender, a lot of designers are moving towards the middle, where they're seeking the middle ground between the gaming software, design software, and traditional industrial design type software. Blender, for instance, is a freeware program that's developed in the Netherlands. You basically create a form, you create an object, apply that form to that object, and suddenly, boom, you have this insane kind of explosion of with a few dials you can dial on and start. And that's where the orchestration comes in. You start literally dialing a couple of numbers here and there, and you can see it updating in real time. And that's a great way to get into it. And back to gaming design software, a huge area where this is happening for a while already is in particle emitters. So, if you create in Unreal, you create a fire or something like that with sparkles. If you take that to the max, then you're talking about also generative chance-based behavior. I've been doing quite a lot of experimentation in the gaming programming field myself, just because the two worlds are getting closer, You see it also with Unreal 5 engine. It's going to completely merge how we start doing product design.
Yeah.
Ian was talking about the Alias software that he uses to model the car. It has a plugin, so you could spin his car. You can click 5 different materials and finishes and color and see it instantly in these different finishes. So basically, he's using his design software and then an extension of that, the render software, as a sales organization tool. With Unreal 5, those things are going to be exploding massively for all of us.
Let's move into 3D printing, another big part of what Ian was talking about. Can you talk about the different use cases of 3D printing? How much of that car is 3D printed?
I think he mentioned it's like 40 parts or something like that.
Wow.
And as you see currently, it looks like the steering wheel, there's a bunch of parts. There's a little exhaust part. Ian started talking about customization, about how in the future you would like to go towards that hyper customization. In this case, that entire carbon frame could be tailored to your weight or to your needs or the height of the mirrors. So I think that's what he's talking about, is that in the future, if you print each part individually as an individual custom-made part for you, again, that opens up customization in so many ways. And that's one of the biggest powers of 3D printing.
Yeah, there's definitely more customization in 3D printing on that than my generic sedan.
Yeah.
What tools and software would a listener need to start working in 3D printing?
You can start with a fairly basic 3D printer. Those things are not that expensive, just the FDM type printer. And then you could look, I'm actually training my kids on Blender at the moment because it's, free software. You just get in, make some parts. It's polygon-based modeling. Like I said, the Fusion 360, I believe, is a free module. Start building some stuff. I mean, this is the age of YouTube tutorials, right? You can basically learn anything you want in a 8-week, or what is it, eight YouTube tutorials. By the end of it, you're really good. You're actually pretty good at rendering and modeling. And then you just send it to you can build anything you want then and start sending it to your little 3D printer. So I think, how do you call it? The entry bar there is pretty low to start experimenting.
Thank you so much for diving into this with me, making me a smarter person, and getting into the nitty gritty with all of this. I appreciate it.
My pleasure. Thanks so much, Tito.
Huge shout out to today's incredible guest, Ian Briggs, for coming in and talking with us about the world's first street legal single-seater supercar. Check out his latest projects on all the socials at Discover Mono. Go buy some merch or buy yourself a car. www.bac-mono.com. Rightbrainers is brought to you by Z by HP, the makers of high-performance laptops, desktops, and solutions for technical and creative pros. Well, that's a wrap on this episode. Thanks so much for joining us. If you want more food for your right brain, visit www.hp.com/rightbrainers. Until next time, I'm Tito Hamzy, and this is Rightbrainers.